Hi there, in this video we will be planning and doing the layout of a regulated power supply. So we've got here some parts, components, a Vera board, and on my right hand side I've got the layout or planning sheet for the project. And so we've got the track side and the component side of the Vera board. And so we're going to have to just identify where it is we have to plan the project. So I would suggest starting the planning with the component side, and we will see where this goes. So on the left is an actual circuit drawing or diagram with information on. We've got all the components on there, and that circuit has to be transferred to a practical project. So the purpose of this is to accurately place components on the Vera board, and we do this by extracting the information from the circuit and making it onto a realistic format, which is the sheet on the right hand side that is a replica of the Vera board. And so the second part with the track side is just to make sure you understand what it is that you're doing. So firstly, you can start by just plotting out and using the same symbols that is on the circuit diagram, and start plotting and placing them and drawing them into the proper format. So here's a bit of a challenge. You see there's electrical connections, and we're going to have to just make sure that the joints are electrically sound, shall I say. So firstly, we start with D1, and you can see there that we've got the two diodes. The black dots, just it's done on the same track to make an electrical connection. And so we will just confirm this just little after this, drawing this, and then go through the circuit again to make sure. As I draw, I also just make notes. I identify where I am. I've got my AC in, and we can just confirm there that those two tracks will be the AC. On the left hand side drawing, we can see there's two lines going to the left, and I'm now already busying with C1, the capacitor. Again, as I draw them, I am also labeling them just to make sure that I'm busy with the correct component. I draw the resistor in, and you can see already the track that is right on top is the same as on the left hand side drawing. So I'm currently busy with the transistor. We've got the base there, a second output A and B. As you can see on top of the left hand drawing, you've got A and B outputs, or input and output. And then we've got the load circuit. Very often the LED is not given in a final project, but that just indicates that there is a load and it is active. And so we've got the light emitting diode there, LED. We're labeling the rest of them. And so now I want to confirm if my components are drawn properly. I've got the top row, which is about 5 dots. I can just, on the actual drawing, confirm it's there. As I'm showing, there's 5 dots, 5 connections on one track. That is output A, which in another video we would have to know where's input A and output B, all those readings at those points. And we've got at the bottom there also about 5 connections. That one track there would identify that there's a connection, electrical connection, and they're not making contact with anything else. The capacitor is across everything, positive and negative. We've got a filter circuit there R1 with a Zener diode and the transistor. Transistor then collects a signal, and it also gives an output signal on the emitter. So with the transistor itself, it has got two measurements that we have to take eventually. Again, make sure even on the left-hand drawing, the actual circuit, do not make a mistake with the collector and emitter and put them on the same track. You can see clearly track A and track B is separated. It's not so clear on the circuit diagram. So your drawing, your representation on the component side must now correspond also with the back of the track. So you're physically taking the Vera board and flipping it upside down or left to right, and that must be a replica of what's happening behind. So almost an inverse picture that you have to draw. So now you must transfer all of that information accurately, or as accurate as possible, to the track side. And so you can't really see the components from behind the Vera board or the track side, but it is how you understand them. You will definitely see the connections. So you can start on the left, and you can see I'm counting 1, 2, 3, 4 dots, and I will just plot out the same components on the same place, but on the opposite side of the track side, because physically, if I take the Vera board and flip it around, this is what the connections would look like at the back. So again, you can see that it is a mirror image of the same drawing, and so we just transfer. This is purely for the purposes of assessment of the project, to see where your understanding is of this project. And so again, you can just count the little dots and holes and plot them out and just draw them approximately on the same places where they are done. Again, your connections must be accurate. It must be 100% accurate. Where you place these on the back side is not always going to be the same place, but your connections must be as accurate as possible. So again, you put your labels in. It is a replica of the bottom drawing. And there we go. We also see the red, blue and black, where it's actually electrical connections, where they are completely separate from each other. That is the circuit.